Welcome to Seasonal Decomposition in Python. In this lesson, you will learn to break down time series data into trend, seasonal, and random parts. No previous experience required. Let us explore using real-world datasets and fun visualizations. Running the cell now. First, let us set up a safe, quiet environment. This code will stop warnings from crowding our screen. We are bringing in libraries for working with data and making plots. Pandas helps us load and work with tabular data like spreadsheets. Matplotlib helps us draw graphs, which is perfect for time series. Running the cell now. What is seasonal decomposition? Many datasets collected over time, like temperatures or sales, show repeating patterns. Seasonal decomposition helps us separate these patterns: trend, seasonality, and randomness. This is a key tool for understanding and forecasting with time series data. Running the cell now. Let us start by loading a real dataset. This file contains daily minimum temperatures in Australia. We will import the data and print its shape. This tells us how many rows and columns we have. Let us preview the first few records to see what our data looks like. Running the cell now. A line plot is the best first step for seeing how values change over time. We will draw a chart of daily minimum temperatures. Notice how the plot creates a wiggly line that goes up and down. This is our time series. Trends or repeating patterns may be visible to your eye. Seeing the data is always helpful before any analysis. We set a title and axis labels to explain the chart. Finally, we use show to display it. Running the cell now. Breaking down time series data. Time series signals can have a trend, the general direction up or down over time. Seasonality, repeating patterns at regular periods, like weeks, months, or years. Residuals, what is left, randomness or noise. Decomposition means splitting a time series into these parts. Running the cell now. Dates are easiest to use when they are datetime objects, not text. We turn the date column into datetime format. By setting it as the index, Pandas now knows how to handle our dates automatically. Running the cell now. When dates are the index, Pandas will handle time-based operations smoothly. Let us print the type and a sample of our index. We expect to see datetime index. This step confirms that our data is ready for time series tasks. Running the cell now. We will use a tool called statsmodels for decomposition. Seasonal_decompose is a simple way to split our data into trend, seasonality, and remainder. We use the additive model, which assumes the parts add up. The period is 365 because our data repeats yearly. Running the cell now. Here we split the time series into the original signal, trend, seasonal pattern, and residual. This plot gives us 4 charts, one for each part. This is a great way to understand what influences the data at different times. Let us call show to make the plot appear. Running the cell now. Sometimes we want only one part, like the trend. The trend shows the long-term movement, here, how temperatures change over years. We plot this with a red line for clear focus. Avoiding the seasonal wiggles or noise makes patterns easier to see. The chart tells us whether values rise, fall, or stay flat over time. Running the cell now. What about the seasonal part? Seasonality repeats at regular intervals, like summer and winter. By looking at the seasonal component, we can see how values bounce up and down the same way each year. Running the cell now. Here is how to see just the repeating seasonal pattern. The green line helps spot the ups and downs, like summer peaks or winter dips. This component repeats every year, so it is useful for predicting cycles. Let us view the seasonality chart. Running the cell now. What are residuals? After removing the trend and seasonality, what is left over is the residual. The residual is the random, unpredictable part of the data. High randomness in the residual may mean the data is hard to forecast. Running the cell now. This chart focuses on what remains after pulling out trend and seasonality. The plot shows lots of small jumps in the data. If the plot looks like pure noise, we know that seasonality and trend explain most patterns. Let us open the chart. Running the cell now. Some decomposition parts can have missing values, especially at the start or end. Let us count missing values in trend, seasonal, and residual. This check is important before any further analysis. Now you can spot where data needs filling or ignoring. Running the cell now. If you want to avoid missing values, you can fill them using the backward fill option. This will fill any missing spot with the next valid value. Now we have clean series for trend, seasonality, and residual. This is great when you want to run other calculations with no gaps. Running the cell now. Let us do a quick mini project with what we learned. Resampling means taking daily data and calculating monthly averages. Grouping the seasonal component by month reveals which months have the largest temperature boosts. We plot a bar chart for all 12 months. This is a great way to spot the warmest and coldest parts of the year. You can now see how the seasonal part guides weather patterns. Let us show the final chart. Running the cell now. Let us get interactive. You can type a number for any month and get its seasonal effect. We make sure to check your answer is actually a number and in the right range. If you give something else, the program gently explains the problem. From this, you learn how to connect decomposition results with values you pick. It is a hands-on way to try out what you learned. If you want, pick another number and run this part again. You will see a message if you type in an invalid month. This is good practice for helping people use your future programs. Running the cell now. Try different month numbers and see how the seasonal effect changes. If you like this video, please remember to subscribe and like for more lessons. You should know there are two main types of decomposition, additive and multiplicative. Use additive if the parts are added. Try multiplicative if changes seem proportional. Here, we repeat decomposition with multiplicative mode. You can compare and see what fits your data better. A subtitle adds one more explanation line on top. Running the cell now. The period tells decomposition how often cycles repeat. If you get it wrong, the parts may look odd or the function may fail. Here, we try period 7, which is weekly, not yearly. Watch the output or any errors. It is a safe experiment. This is a good way to test and understand how settings affect results. Let us print out any problems we find. Running the cell now. Let us save the trend to a file. This helps if you want to use the trend elsewhere, like in spreadsheets or for sharing with a friend. A simple to _CSV command writes out our data. Running the cell now. Recap, what have we learned? Loaded real-time series data. Plotted and explored changes through time. Broke the series down into trend, seasonality, and randomness. Used the decomposition to spot patterns, cycles, and surprises. Saved our results for future use. You are ready for time series analysis. Running the cell now. Challenge, try more. Can you? Repeat this for another year or different temperature dataset. Apply decomposition to the airline passengers dataset. Explore trend and seasonal changes for your favorite city. Share your ideas or questions in the comments below. Thank you for learning with us. Enjoy time series in Python. Running the cell now. Keep practicing and experimenting with time series. Remember to subscribe to our YouTube channel for more beginner-friendly lessons.